Hello, my name is Keith Rucker. Today I'm going to be starting on a project that's actually not related to the matcher restoration that I've been working on for some time now. This is a little job I'm doing for a friend of mine that has helped me out on a couple of things. And anyway, he has a woodworking shaper for putting profile knives on to cut moldings and what have you. It's made by Greenlee. I don't really know the vintage of this machine, but when he got it, it came with a couple of spindles like this right here that you put the different shaper cutters on. And the shaper cutters have different diameter spindles that they go on. This one here happens to be 1.25 inches. And I think he has several, but one of them that he doesn't have is a 3/4 inch spindle, and he happens to have a good bit of 3/4 inch tooling from another previous shaper that he had owned. So he's really wanting to get a 3/4 inch spindle for this. So the way this works is this screws down onto a little stub on the machine, so you can change these spindles out and put different spindles on for different size cutters. So a couple of things we're going to be doing regarding this. Number one is we're going to make a new spindle that has a 3/4 inch spindle up here. This is what it looks like. So, we got the spindle, the top part here, this is Acme threads. We'll have to make a nut to go down on that as well. This one here, this 1.25 inch one, this is Acme 7 threads per inch, which from what I can tell is kind of an odd size. I mean, it was out there, but you don't, doing a little bit of research, you just don't find a lot of Acme 7 stuff out there. In fact, I got to make a nut. This is a nut off of a similar spindle shaper, or shaper spindle, but it is 8 threads per inch Acme, which is probably a little more standard, so it won't go on there. This one here also happens to be left-hand threaded, whereas this one has a right-hand thread. So, and the reason for the left-hand thread there is a lot of times on these old woodworking shapers, you'd have a double spindle shaper. It'd have 2 spindles on it. One of them will be turning clockwise, one of them will be turning counterclockwise, and you always want your nut to go on in the direction that as it's spinning it is tightening. So you would have one that would be right-hand threaded and one that would be left-hand threaded. So the one we need is a right-hand thread. And so this nut here he sent me as just an example of what he wants, but we're going to have to cut a 7 Acme thread right-hand thread nut to fit this spindle, and then make a whole new spindle using this one as a model with a 3/4 inch spindle. And I think I'm going to be using Acme 12 threads per inch on that, which again, when you normally think of Acme threads, this is more like a fine thread with Acme, and I don't know that that's a standard size for 3/4 inch, but that's what a lot of other shapers evidently uses 12 threads per inch. So that's what we're going to do. So we'll have to make the spindle and also a 3/4 inch nut to go on that. So with this project has a couple of challenges, just technically or whatever. Obviously Acme threads, I've done Acme threads before. They're not particularly different from doing regular threads, except for a little bit of setup, and there are a few little differences. So when we get to cutting those Acme threads, we'll do that. There's going to be some internal threading on this project. So up inside this piece here that screws down, this is a 1.5 inch 9, I think, but that's a standard 60-degree thread. So we'll have to do some internal threading there. We'll have to do the internal Acme threading on the nut. So this project's going to have some interesting things to it. So for today, what I'm going to start with is working on making the new 3/4 inch spindle. But before I can actually start on the spindle, I have to make the male part that fits up in here, because what I want to do is I actually want to create this piece that it's going to screw into, and I'm going to use that as what I'm going to actually mount this on the lathe to turn it, so that as I'm turning this, it's going to be turning exactly true with the spindle. I don't want to make it all and then put it on there and then run the risk of having some run out in the spindle. So if I basically make a driver piece that is exactly like what is on the shaper to turn this on, everything should come out just right. So Fortunately, again, he sent me some pictures of what that stub looks like on his shaper. And so we're going to basically make this a piece here that's like this, but on something we can mount in the lathe. And he also sent me a little drawing with some dimensions on it of what we're going to be doing, or what I need to make. So I've got something to work on. So over here on the lathe right now, I have a piece of just steel, and we're going to turn this down, and basically on the end we will make the exact duplicate to what is on the machine. I'm going to turn this down up here just so that I can chuck this back up in the lathe. I need a good machine surface that's on the same plane that I cut this on, that I can then use that later to indicate on to get this running true in a 4-jaw chuck, because I'm going to have to take this out when I make the spindle and use this to test fit to make sure everything's fitting, and then I'll then turn that back around. I'll make the when I start working on the spindle, the first thing I'll do is do the bore this out, do the internal threads, make all that fit, then turn that around, mount it on this piece that I'm going to turn here, and I'll turn the spindle part. So this is going to probably end up being a multi video, and quite honestly, it's going to be spread out over several weeks, just simply because I'm going to have time to do this today. I know that I'm not going to have time to get started on the spindle. That'll be another project for another week, but we'll go ahead and get this part done. So anyway, there you go. That's what we're going to work on, so let's get started. We've got a piece of 2 3/16 inch stock in the lathe here. This is just, again, a piece of scrap metal that was out on the scrap pile. Looks like an old piece of shafting of some kind off of who knows what. So I don't know what grade steel this is for what I'm doing. It really doesn't matter. So we're going to get started by facing this and putting a center in the end, and we'll get going. See what our speed looks like. Looks all right. A little oil on there. And now we'll go ahead and start turning this down. This is the depth of the threads that we'll be cutting on there, so we need to basically turn this down to what is that, 1.562 is where we need to start at. So we'll just put a little oil on there. And we'll take a pretty heavy cut on this to start with. I'm removing about 100 thousandths from each side, so this will be a 200 thousandths cut. We'll make another 100 thousandths. We're within about 50 thousandths of where we want to be, so I'm just going to take about half of that. So we're going to take about 25 thousandths. Go right there, and then see where we're at for a final cut. We're getting down real close here, so This bottom end of this needs to be 1.563 to match the other piece. So right now we're at about we're at 1.570. So we need about 7 thousandths more to come off of this. Let me see if I can dial in 7 thousandths here. 2, 4, 6. That should be about right there. Alright, we're at 1.564. So we're about 1,000th over. Actually, he had that measured at 0.5 thousand. So really we're about 0.5 thousandth over. So I think I'm just going to take some emery cloth and we'll polish that up. And I think we'll be right where we need to be. Perfect. 1.563. Right where we need to be. Alright, there's a step in the bottom of here, 342 thousandths, and the top part gets turned down to 1.5 inches. So I'm just going to put use my blue Sharpie. Looks like I need to get a new blue Sharpie. Alright, this is about 63 thousandths over. So I'm just going to take about half of that and we'll get another measurement here on the next run. About 30 thousandths to go. the original, it has a small diameter, turned down to about 1.400 right here, so just down about a 125 thousandths. So we need to take about 100 thousandths off total. 2, 4, 6, 8. It should be right there. Just a little bit. Knock that burr off to the file. Okay. We're now ready to start threading this. So we're set up for threading this now. This section here is the part that's going to be threaded. That's turned down to 1.5 inches. We're going to put 9 threads per inch, which is to match the little stub arbor that this fits onto, that this spindle will go down onto. And to do that with, I've got a carbide insert threading tool in here. So this is taking a cutter that looks like this. On the end, of course, you got your profile. That's a TNMA style carbide cutter. I like this type of cutter for threading on external threading because you just got a lot of strength below this, particularly on coarse threads such as this one. I also use the lay flat type inserts a lot, but for real coarse threads, real heavy cuts, I really like this TNMA type of insert. So that's what we're going to use. Go ahead and make sure we got everything set up. So first thing I like to do when I'm threading is just do a real light scratch test and make sure that I have the machine set up in the right thread. So I slowed my speed down. Let me just put some, I'm just going to take my blue Sharpie here and just put some bluing on here so that we can see that scratch a little bit better. That should work. I'll come in here and just touch off right there. And I'm going to set my cross slide now to 0 so I can return back to that. I have my compound set to 29.5 degrees. This is a 60-degree angle on here, so that's half that included angle. And I like to go to 29.5. Some people say 30. I was taught 29.5, so that's what I'm going to go with. And so we'll do all of our feeding off the cross slide, so that we're always cutting off of this back edge over here. We'll be feeding in this way. So you're always getting a full cut on here. We're never feeding straight in. We're feeding in at the same angle as this edge over here. So you're always cutting that full face on the front. So everything should be good for the scratch test. Check something here real quick. So we're 9 threads. That's an odd number. So on my threading dial, I have to engage on one of the numbered dials. I can't do the halves in between. You only do those for evens. So on any of those, we can engage the half nut. And I'm going to wait for one to come around here. Here we go. Pull out, come over here, go back to 0. Alright, so now I can see on here my threads per inch. I'll take my threading gauge, which is on 9, and that looks perfect. So we should be ready to start threading. So I'll always feed in on the compound, and we'll start with a fairly heavy cut. As we get deeper in there, you're taking a wider cut on this front edge here, and you have to take smaller cuts. But to start out with, you can go pretty slow, pretty heavy. So get a little oil on there. I've got about a 10 thousandths cut on there. Wait for a number to come around on my dial, and engage. We are getting real close. It's still a little tight. We'll take off a few more thousandths and test that again. Perfect. All right, I think we got this finished here now pretty much. So just to show you here, the stub arbor matches what's on the machine. Here's the, let me blow this out real good. Here's the spindle that I was sent to test it with, and that comes right up on there. That seats on the bottom of that stub arbor here, and looks like he's got a little bit of run out in this arbor, which that's not to be unexpected. That's an old arbor that's been being used for who knows how long, so probably not a big issue on that machine, but anyway, nothing I can do about that. But this now gives me something that I can basically turn the spindle on when I make the smaller one. So this is pretty much done, and this will also give me something to test when I do this inside bore here. On the new arbor, I'll have a piece to test it with to test fit that thread in there. So we're just going to do a few little finish up things on this. I'm going to finish this nose piece up here, turn that down just a little bit more and get a good chamfer on that. I'll probably run some emery cloth on this surface here, and we'll just part it off, or I'll just put it in the bandsaw and cut it off. This end's not going to matter. And this will give me something that I can chuck up in the 4-jaw chuck right here later on, and still have a surface here on the end that I can indicate on to make sure everything is running true when we get ready to use this to turn. Because we'll have to take it out of the lathe and use it as a test piece on the other, when we make the other piece, and then put it back in the lathe to turn on later on. So just a few more little things and we'll be done with this. So part one of the project and making a new spindle for this Greenlee shaper is done. We've got the mounting arbor here to mount this on, and also to test fit the internal threads when we get to that point. So anyway, this will be, again, when we start on the new spindle, first thing we'll have to do is make this end. And while this is on the lathe, I can use this to test fit, make sure everything's going to screw on fine. And then once I get this part done and flip it around, this whole assembly will mount into the lathe. I'll chuck this in the 4-jaw chuck, indicate it in to where it's running good, screw on the piece that I have the internal threads there, and then I will use that to actually machine the rest of this out to turn the spindle on and do the threading up here. So we'll get on to the rest of this project probably in a couple of weeks when I get back in the shop. And for today, I've got a couple other little small things I want to get done, so this is all we're going to work on this today. Thank you for watching, and we'll continue with this project later.